Huh? Sorry. All right, now how do we actually solve these limits without tricky stuff? Okay, so we're looking at just one function at a time. Let's look at this function. So the first thing you do with any limit is you do what? Plug it in. Okay. Yeah, so let's plug it in and see what happens. Negative 3 squared minus 3 minus 6 over minus 3 plus 3. End up 0 over 0. 0 over 0. That's a special thing in calculus. It means it's possible, but do it a different way. Okay, so what we're going to do is we are going to factor and simplify. Now, when you do, yes?
Is this only for when the top and the bottom are both 0?
Yes, correct. Only when the top and bottom are both zeros. So in this case, what we're going to do is we're going to factor and simplify. So when you do this, you have to keep the limit sign the whole time.
Oh, I see.
Is this still with me?
Yeah.
Can you put your calculator away? Okay, so that's going to be x plus 3 times x minus 2 over x plus 3. And what we can see is that this factor cancels. Keep the limit because you didn't substitute yet. You always have to keep it until you substitute. So limit as x goes to negative 3 of x minus 2. Now you substitute, so the answer is minus 5. All right, let's have you guys practice. Okay, so only when you have a 0 over 0, then you do something like this. Okay, so let's have you practice with one of them. Let's try this one. Okay, so hopefully you got to the correct answer. The answer is 5/8. Good? Okay, let's try another one. This is, not hard stuff. It's just kind of like algebra review, almost. Let's try this one here. Okay, if you put in 3 right now, you will get 0 over 0. So this is just a practice of can you simplify this fraction? Okay, try it. All right, let's make sure we can do this. This is an important skill. Okay, limit as x goes to 3 of 3 minus x over 3x over x minus 3. So you can see that x minus 3 is probably going to cancel, but it's just in the wrong order, so we're going to have to change that direction. So take the negative out, x minus 3 over, and hopefully you remember that two denominators will combine. So that is a 3x times x minus 3. So that cancels, so we have a limit as x goes to 3 of minus 1 over 3x, so the answer is minus 1/9. Okay, so, skills you got to remember. Next part, and also this is a skill from last year. When you have a 0 over 0, that looks like this. You have a radical. Okay, when you have a radical, you're going to have to rationalize by multiplying by the conjugate. Okay, well, we have a radical in the numerator. What is the conjugate?
Square root of x plus 1 plus 1.
Yes. Okay, and then make sure you do that to top and bottom. Okay, remember on the top you have an a minus b times a plus b, so that's an a squared minus b squared. Use that shortcut instead of doing crazy things. So that's a minus 1 over x times, make sure you put parentheses. If you don't, it's going to be very crazy. Okay, so that 1 cancels, and you can see x will cancel as well. So you basically have a limit as x goes to 0 of 1 over square root of x plus 1 plus 1. And when x goes to 0, is just 1/2. Okay, so this is just, make sure you multiply by the conjugate. Which part?
Never mind. I mean, no.
Okay, let's do one more problem and we call it a day. You guys got it? Copied everything down?
No.
Okay, let's do one. This one.
Wait.
Ooh, I'll show you. multiply the conjugate? No, 1 minus 1 is 0, but it's still have x. X and x cancel, so it's just 1.
I missed number really kids.
Wait. First one? You got it.
Oh my gosh, why can't I do that?
Okay, what's the answer? 1/4? I think. I think it's 1/4. Wait a minute, 1/4. Multiply the conjugate. So it's a +2 in the denominator. Ooh, what's going on? What you watched on the video is this squeeze theorem. So the question is, what do we do? So for example, how does squeeze theorem work? Well, in squeeze theorem, you may not do that many homework questions on it. Hold on. You may not do that many homework questions on it, but it's actually a very important theorem. It does come up on your test sometimes, so please make sure you understand. Okay, so first, about the squeeze theorem. Squeeze theorem works because whatever function you're trying to find is squeezed between two functions. So basically, you have three functions you're looking at. F of x is stuck between h and g. Okay, so first thing, squeeze theorem, you gotta have something squeezed in between. Sometimes we call that the sandwich theorem as well, because it's sandwich in between, but it means the same. So F is stuck between H and G. Okay, so that is for all x not equal to C in some interval about C. And we know that, so we're trying to find what is going on with F. Now, we know that the limit for H and G go to the same limit. Okay, so if the limit for H and G goes to that same number, which is the most important thing, then because F is squeezed between G and H, it must have the same limit, right? So you have three functions, G, F, H. If both G and H go to the same number, F being in between has to go to that same number. So that's called the squeeze theorem. So somehow, if we cannot figure out what this limit is for that middle one, if we can figure out what is going on the two ends, and they both go to the same number, the middle one must go to that same number, because that's just how it works. You're squeezed in between. So then what we want to do is figure out the two limits on the two ends. That's the idea. Yes?
What if they don't go to the same number?
Then you cannot use the squeeze theorem, because you cannot squeeze anything. It's not going to the same number. Yes?
So you can only use it if it goes to the same number.
Correct. Right. Or else it doesn't make any sense. You don't know what that number is. Yes?
How do we know when to use it?
Great question. So these are all tricks on how to find limits. So you use them when it's appropriate. And if it doesn't work, then you try some other tricks. I'm going to teach you more tricks throughout this chapter. Okay, so let's say, for example, this one. Find the limit as x goes to 0 of x squared sine 1 over x. All right, write this question down first. Okay, so you should, this is a classic example. You should write it down. That way you can study this later. Okay, so the question is, first, when we're trying to find limit, kind of like what I told you on Monday, what is the first thing you should do? Plug it in. Don't try to use squeeze theorem. Don't try to use any tricks. Just plug it in and see if it works. If it works, what's the point of using complicated stuff? So if you plug it in, you get 0 sine 1 over 0. What is 1 over 0? Undefined. Therefore, we cannot figure out what the answer is. Therefore, we got to use something else. Okay, so I'm showing you why we have to use squeeze theorem, not just like if you see this, use squeeze theorem. But, the reason being, I cannot figure this out. So we don't know what that means. What is 0 times undefined? So we're going to use squeeze theorem. So in squeeze theorem, what you're going to do is first pick something, usually something with a trig function. Okay, so you're going to start with that. So then you say, well, I don't know what's going on. Let's find the limit as x goes to 0 of sine 1 over x. So that's what I'm going to do first. Then you ask yourself, is sine kind of stuck between some numbers? So, if you just look at the sine function itself, negative 1 and 1. So sine function is always oscillating. So y is always between negative 1 and 1. It's not possible to get out of negative 1 and 1. It's always going to oscillate. So this is always between negative 1 and 1. Okay, so we're now squeezing this function between two functions. One of them being negative 1, the other one 1. Okay? Next, I'm going to add on a function. So we know that limit of some function times some function, we can split it into two functions. Limit of two functions. So I can say this is the same as limit as x goes to 0 of x squared times limit as x goes to 0 of that sine 1 over x. Yes, question?
Will it always be negative 1 and 1? Or does what's inside the parentheses sometimes change it?
No, because sine by itself will not change. It's always oscillating between negative 1 and 1.
It only works with cosine and sine,
Mostly, yeah. For now, yes. Okay, so when we multiply that limit, the new limit right here, to this function, we multiply the same thing to our two ends. So we multiply the limit as well. Yes, you had to fully write it out. All right, so now this is pretty much what I'm trying to find, this middle part, right? This is what I'm trying to find. If I can figure out what the two ends are going to, then maybe I can squeeze this in between. So let's look at this one. Okay, so negative 1 is already negative 1. What is the limit as x goes to 0 of x squared?
0.
0. So 0 times negative 1 is 0. So that part is 0. And then this part is the part that's in between that I cannot figure out. Okay, on the right-hand side, we have 1 times limit as x goes to 0 of x squared. So what is limit as x goes to 0 of x squared?
0.
Also 0. So 0 times 1 is 0. So that goes there. So my function is now squeezed between two zeros. So then what is my limit?
0.
0. Tay, I have a question.
on like a test, would we have to like label everything like this, or just if we got the answer?
No, you have to write everything.
Wait, even like the
Label?
negative 1 times limit x goes to
Yes.
0, you can't just write x or
No.
negative x.
Okay, just no, this is the norm. You have to write everything. This is a proof. This is not just do you know the answer. So if it's a proof that they want to see your process, you got to write everything out. If it's just a multiple choice, then yeah, pick your answer.
But it's just find the limit.
If it's something for you to write out, you have to write it out.
So let's show your work.
You have to show your work. Okay, let's go on to this one's exactly the same. Let's try this one. This one's more interesting. Okay, write this one down. Let's try this one. Okay, on this question, what should we do first?
Plug it in. Always try to plug it in.
Ah, very nice. Plug it in. So you should get 0 times e to the sine of 1 over 0. Is it something we can evaluate? No. So we don't know what it is. So what should we do? Okay, so what should we start with?
I think we should do the e sine 1 over x.
Yes, but we cannot enclose e between two numbers, right? E on the one side is 0, the other side is infinity. Huh? Sign? Okay, so just the sign part. Okay, so we're going to just look at sign. So limit as x goes to 0 of sine 1 over x. All right, so same reasoning as before. Sine is always stuck between -1 and 1. So we're going to stick this between -1 and 1. All right, we're kind of building up that function back to where the original question is. Okay, what's the next thing we need to do to make it become the original function? Raise it to e. Raise it by e, or raise it by e. So basically, so this is going to be e to the sine 1 over x in the middle. So then now what do we do with our two ends? Raise both of them to e. By e, by e. Okay, one side is going to become e. The other side is going to become 1 over e. All right, we're closer to our final function, but we're not quite there. What's the last thing you need to do? Multiply by x squared. So limit as x goes to 0 of x squared e to the sine of 1 over x less than or equal to, and then I have an e times limit as x goes to 0 of x squared, and then same thing on the other side. So that is 1 over e times limit as x goes to 0 of x squared. All right, what do my two sides go to? 0. So then what is the limit? 0.
What do you start with the sign?
Huh?
What do you start with the sign?
What if you start with,
Wait, why do you start with the sign? And
why do
say e?
not e? Because e is not stuck between two numbers. E, if you remember e to the x, one side is 0, the other side is infinity. So it's unbounded, and we cannot just multiply a 0 to an infinity.
Are these answers always 0?
No, because we can use the squeeze theorem in other numbers when x is not going to 0. Right? This is only working out as 0 because x is going to 0. If x is not going to 0, then it's going to be different. Not always. You should always check.
No, but if it's a,
Uh,
So if x is going to 0, is it always 0?
we don't know. You really should check. All right, everyone, come back. Let's have you just practice with this easy one, and then just practice your proof writing strategy. All right, so in this one, you're going to start with the cosine function. Okay, that is going to be stuck between 1 and -1 again. So then you build this up by adding that x squared there. Okay. And then the two sides are going to go to 0. So therefore, limit as x goes to 0 of x squared cosine 1 over x squared is 0. Okay, so this is how the squeeze theorem works. Please review it from time to time. We're not going to do a lot of it, but somehow AP likes to just give you like the questions that don't show up a lot. So please be careful. Okay, so we're now going to, can you guys hold your question for later? We're now going to trig limits. So let's look at this first. First of all, let's have you guys take out your calculator and check. What is the limit as x goes to 0 of sine x over x? All right, so what is the limit as x goes to 0? 1. Okay, it's not defined, obviously, because you have a denominator that will be undefined at x equals 0, but it is 1. Now try it the other way. X over sine x. What'd you guys get?
Also 1.
1, correct. So these limits are, you cannot find by doing some algebraic work, but you can see from the graph or from table that it is 1. So what you're going to do is memorize it, that it goes to 1. When you see a sine x over x or an x over sine x, and x goes to 0, which is the most important part. A lot of people see this x over sine x, they just think 1, but they did not look at where x goes to. When x goes to 0, it's 1. Okay, we're going to use that fact to solve some trig limits. So for example, this one. Actually, before then. Sine x over x and x over sine x as x goes to 0 is 1. Now, this applies to sine nx over nx. So we can change that number that x is multiplied to, top and bottom, and if both of them are the same, it still goes to 1. So we are going to have to keep that fact for a long time. So same thing here. If it's nx over sine nx, it's also 1. So you just need to remember that the top and bottom has to have the same number of x. Okay? So let's look at this question. Limit as x goes to 0 of sine 4x over x. I can solve it if it's sine x over x, but there's a 4 there, so that's kind of a problem. So if I want to use the limit rule of taking out that sine 4x, then on the bottom I have to have a 4x as well. So how do I make the bottom have a 4? Multiply by a 1, which is 4 over 4. That way, I make a 4x in the denominator. So basically, I'm going to show you the long way here. So it's basically 4 sine 4x over 4x. Now you can see that I have a sine 4x over 4x, which we know that limit goes to 1. Right? So I'm going to do this the long way first few times until you kind of see it. So this is really 4 times the limit as x goes to 0 of sine 4x over 4x, right? And then we said sine nx over nx is 1, so that whole thing is just 1, so then this limit is 4. So for the first few times, if you're not sure if you got it right or not, you can graph it and then check, right? When x is going to 0, is my y around 4? It is, okay? All right, let's try another one. So that was a simple one. This one. Okay, so remember, I can cancel it out, or I can make that limit go to 1 if the top and bottom are the sine x over x or x over sine x. So what should I do with this one? Well, is there a sine x over x?
Yes. Yeah.
Yes, already, right? So this is basically 1/3 times sine x over x, right? So I already have a sine x over x. That part already goes to 1. So the answer is 1/3. Okay, so you want to look for that pattern of nx over x, and sine x over nx. Okay, moving on to the next one. Okay, so now let's look at this one. This one's a little bit trickier. Okay, so I have it. So you want to just look for the sine part first and then figure out what you need to do to the x to make it cancel. So I have a sine 3x. I don't have a 3x. What should I do? 3 over 3. We can only multiply by 1. So we cannot multiply by any number that's not 1. Okay, so if I do that, I have a limit. I'm just taking this the long way. I'm sure you can start taking shortcuts at this point. So that's 4 times 3x over 3 sine 3x. Okay, now what does this limit go to? 4/3. Can you guys all see that?
Yeah.
Okay, so 3x and the 4 sine 3x cancel, so it's just left with 4/3. Got it? Okay, we're gonna do a trickier one now. Let's do this one. Tangent. So you gotta recall what tangent is. Sine over cosine. So I'm gonna start taking shortcut because you guys are in calculus. So sine over cosine, which is just sine over 4x cosine x. So if you don't know how I get there, it's just sine over cosine over 4x, and then that denominator combines. What should I do? Okay, first of all, remember what cancels is sine, right? So is there something that can cancel with sine already?
Yeah.
X. So that's already gone, right? That part always become 1. So we are left with limit as x goes to 0 of 1 over 4 cosine x. Now what?
Plug it in.
Plug it in. All right, plug it in. What do we get?
1.
What's cosine 0?
Oh, 1.
Yeah, 1/4. So don't be scared by the cosine. You're like, oh, it doesn't cancel with anything else. It doesn't need to. Cosine 0 is 1.
Ooh.
Okay. All right. Now let's go on to more intermediate mode.
That's easy.
Okay. This one. Now I have a sine and cosine and some binomial. Recall pre-calc. Okay, yeah, something is tricky with that 1 minus cosine.
Oh my gosh.
Oh, you can change
Huh?
Yeah.
We cannot change 1 minus cosine.
Because
Huh?
it would be
Can I-
minus cosine squared.
Yeah.
Yes, we do need a 1 minus cosine square. How do we get there? Huh? 1 plus cosine.
Can we just plug in? Oh no.
No, we're going to get 0 over 0. But that's a great question. Yeah, why can't we just plug in? Yeah, you should always plug in and check. We do end up 0 over 0, which is why we need all this. Okay, I'm going to work this out to a certain point and let you finish. Okay, so this is going to be sine square x times cosine x times this binomial that looks very long now. On the denominator, we have a 1 minus cosine square. What is 1 minus cosine square? Sine squared. Okay, I'm going to let you and your partner finish this question. Let me know when you have the limit. Okay, first of all, this denominator becomes a sine squared. So that cancels. And all we're left with is limit as x goes to 0 of cosine x times 1 plus cosine x. And cosine x of 0 is, 1. So then this does work, so it's just 2. All right, let's have you try a easy one. This one, number 9 here. All right, what should we do to solve this?
Multiply by 1/5 over 1/5.
Yes, 1/5 over 1/5. That's going to cancel. The answer is 1/5. Okay, I think you guys are ready for a harder one.
How does it cancel?
Sine x over 5, and then on the denominator, it's a 1/5 x. So they're exactly the same, so they cancel.
You read the top as
X
sine
over
x
5
over
and
5 times 1 over 5. You write the bottom as x over 5. They cancel. You're left with 1 times 1 over 5 on the top.
Okay, let's have you guys try this one.
Wait.
First of all, check. Do we get 0 over 0?
Yes.
We do. So that's a problem. So what should we do to get rid of this cosine? Because obviously I need a sine so that things can cancel.
Double cosine.
Times what?
1 plus.
Yeah, 1 plus cosine 2x. Okay, so go from there. Okay, so what is
Oh wait,
the numerator become?
x plus cosine 2x squared.
1 minus cosine squared 2x,
Yeah.
right?
So
Okay, 1 minus cosine squared 2x. Remember your Pythagorean identity. Sine squared plus cosine squared is 1. It doesn't matter what x is. So then this becomes, what does the numerator become? Yeah, sine squared 2x.
Oh, wait.
Now we have 2 sines, okay? We have 2 sines. We got to cancel both of them, okay? In the numerator, I have 2 sine 2x. So I got to get rid of both sine 2x's. So I have, in the denominator, I only have 1x. That's not enough. So I need another x, right?
So
In order to cancel, but that doesn't work because I need
2x.
2 2's.
X.
So,
Multiply by 2. So multiply.
okay,
Two twos.
let's look at this part. This part becomes limit as x goes to 0 of sine 2x. Sine 2x, right? Sine squared 2x essentially means that. X and then that, right? So then if I want to cancel both signs, I need 2x in the denominator. Yes.
Well, wouldn't x times x be x squared?
Yes.
Huh?
Yeah.
Okay, so yes. So in the denominator, how do I even cancel this stuff? So how do I even cancel the first one? 2. So let's put a 2 there. How do I cancel this 2x?
You need another 2.
I need another
And
2x.
yeah, and another.
Right, top and bottom.
4x squared is equal to 2x times 2x.
Right.
Yeah, that's much better.
Okay, so that cancels. That cancels. Limit as x goes to 0 of 2x over 1 plus cosine 2x. Now what?
Where the 2 on the top?
Oh, sorry. 4? Sorry. Okay, now what? Plug it in. What do you get?
Good question.
2, 3,
You don't get it.
Oh, 2.
0.
0. 0 over 2, which is 0.